Hello everyone and welcome back to Step by Step Electronic by #20. Today we'll be looking at microcontrollers. We will check the different type as different family of microcontrollers are just passing through, but we will be focusing on this brand here, Pic16f84A. We will see the architecture of it as input output and what we have, what we offer. We'll start with the programming of this microcontroller with a PicC compiler, and we will do that through a simple project. We will see it later, and in the end, as we used to have a small evaluation linked to the description. So here we are. Just microcontrollers are most common programmable device, so what can be used in most of the automatized complex system, and can offer many functionality like an analogic numeric converter as serial communication and very others functionality. And those functionality are depending at the brand and the reference of the microcontroller, and also the needs of the system or the project that you are working on. So there is so many type of microcontrollers or family. There is Pic10, Pic12, Pic16, 17, and 18, 24, and recently appeared Pic32. The difference between them is first in the internal memory. That means about the size of the program, what they can hold, and also what functionality they can offer. For example, there is difference between the one what we'll see today, Ch3 F84, have, for example, two ports, one with 5 and one with 8 input output like pins, and the next microcontroller we will be seeing in the future will be 16F877, what have 3 ports. That means more input outputs and also offer more functionality than the one what we will see today. Now let's take a look around this microcontroller what we see today. As we see here, we have 2 ports, port B, 8 input output, and port A have 5 input output. And this particular microcontroller, as we see here, we have a 1024 word programming memory, 86 byte as RAM, 64 as programmable electronic memory. Have limited functionality as microcontroller just for beginning purposes, and as interruption we will see that in the future interruption is it's how the name is said, interruption. For example, you are doing something and someone call you out, for example. You will go to do events and you will come back to continue what you are doing. So this is the general functionality of the interruption. So we have the external interrupt, what is basically on this particular entry or pin, and also the timer interruption in this particular pin here in A4 from port A, and also we have interruption on any changes in at those 4 pins here from RB. We will get to that in the next chapter probably. So here is the internal architecture of the Pic16f84. Most of the microcontrollers, they have integrated an analogic logic unit as the CPU of the computer, so he can make arithmetic and logical operation. That what make him make the microcontroller to be an asset for embedded system. And have a mixer, and this is the statue register instruction to and addressing. And okay, I will be linking even the full sheet for this peak if you want to know more about it. But let's get to the practical things. Okay, as we say, we will use PicC compiler, and this is just a preview of it, and we will pass through it with this example, this simple project. It's just simple traffic light, red, and after go to green, green to red, passing through blinking yellow. So this is our project here. Okay, so we have the pin on the port P3, it's output, 2 is output, and 1 is output. Okay, we need to keep this in mind. Now let's go to start our project. So we go project wizard, so we'll be making our on the desktop on electronics, making a folder here, exercise, we will save it here, simple traffic light. Okay, save. Okay, we have here almost all the brand from the Pic family. We need to check to find Pic16f84A, what's here. We will be using 4 megahertz as clock, and you have here some, for example, like examples of communication. If you want to enable the serial communication, and for the moment we will just focus on input output pins. We have here port A and port B, so we'll focus on those 3 pins. Pin B1 as output, B2 as output, and same B3 as output. And for the moment, that's all what we need. And press OK, and we'll generate this structure to can start to make our program. So our program will run in a loop, so directly will be, this condition will be always true. Will be code, or will be here. So as a beginning, we will be using a lot with the help of this program, what is so simple. You just need to go here and index, and you have the syntax of any instruction what we need. Okay, as definition, as anything, just we need to look for it here. For example, we need output. Let's see what it gives us. For example, this one, output A, the value that this one will output a word in all the ports, but don't we need that? We need a bit by bit, so we have output bit here. As I give even an example of the syntax, we have output bit, which pin and which value, 0 or 1. Okay, so let's start. So as an initial, we need first, okay, will be lighted the red light, so we say output bit, so we spin P3, and now the value 1. Yeah, and because as we see here, pin B3 is linked to the red light, red LED. Okay, next will be output bit, pin B2, and the value 0, because we want it to be switched off. And the same, we'll do the same for the green one, output bit, pin B1, 0 also. And here, because the clock rate is too high, we need to make a delay to can see the result of our instruction. So will be delay ms in millisecond. We put 2000, that means it's almost 2 seconds. Okay, now we will pass from red to green. We will take all of this, paste it. We need just to change the value to switch off the red, switch on the green, and now we need the red one to stay, switch it off, and the green one to switch off. Okay. And here we will do a blinking for the yellow um, light. Sorry. Okay. For that we will use for loop as e equal 1, e smaller or equal to 10, and plus e incrementation. Open this one, close it. Okay, so in this one we want it to blink. So let's see again. Help. What we will have? We have output toggle. What do this instruction? Toggle is just change the state of the output. If it's 0 will be 1, if it's 1 will be 0. That's what we want. Just change the state of the output. So we'll be using this instruction here, output toggle. See, just copy and paste. Ctrl V. Okay. So what you want to toggle? The pin B2. And we will put delay. This time we will put 200 because we are going 10 times as we see here. So is 10 multiplied by 2 is 200, sorry, will be 2000 milliseconds. That means 2 seconds. But here we are using a variant, but we don't make a definition for it. So we come here, int, that means integer e equal 0. It is an initialization. Or you can just define it here and to initialize every time we start the loop, e equal 0. Okay, and this will be our program. But first, before to try it on, we need first to compile it to check if we have to make a mistake, and also we need to build, because with this action we'll build even the hex file what we need to load it to our microcontroller. Is the program in binary or hexadecimal what can be loaded to the microcontroller to can understand what we are writing here. Okay, let's come back here as we say in the last episode, last chapter. To modify the property of a component, you just need to right click, and we will go to this one here to can put the hex file. Okay, and let's try it now. We'll play. Okay, starting red, getting, passing through, again is blinking yellow. Okay, for the connection here, this connection in the simulation is not obligatory, but it is when you make your electronic card. This one is connected to the oscillator to can give the clock rate for the microcontroller. You need to be protected with capacitor, 22 picofarad, and for this pin here, it's the initialization or polarization pin. So you need to be in the 5 protected by a resistor, and this button here is for to reset the system. Something like this, we reset, come back from the beginning. So here we are, we finish this chapter today, and evaluation will be linked down below, and also this schematic and also the program if you want to follow along. So have a good day. Thank you for your attention. Bye.